Thank you for joining today's webinar, Safety Management for Electric and Gas. This webinar is part of the GeoConnects webinar series for utilities. My name is Tom Coolidge, and I'm Esri's Director, Gas and Pipeline Industry Solutions. As today's webinar facilitator, and on behalf of all of my colleagues, I hope you'll find our time together today to be interesting, informative, and helpful to you and to your organization. I am joined today by three colleagues, my Industry Solutions colleague, Pat Hull, and two solution engineers, Jessica Altamira and Tyler Pilarczyk. All of us are members of Esri's Utilities and Telecommunications team. The 2019 GeoConnects webinar series has been put together to give you a more complete understanding of how a modern GIS platform can be used within electric and gas utilities. The series opens today with a focus on safety management. In our next webinar in June, we'll focus on grid modernization. This July, the GeoConnects community will gather at the Esri User Conference. This August, we'll look at asset management. Then the seminar series will wrap in early October with a focus on the customer experience. Later in October, the GeoConnects community will gather once again at the GeoConnects conference in Atlanta. If you can't make any of these particular webinar sessions, don't worry. All the webinars are recorded and the links will be shared with registrants. So don't forget to register to make sure you get the links, even if you can't attend the actual webinar itself. Here's a brief overview of today's agenda. First, we'll look at utility safety. Then we'll be looking at regulatory compliance. After that, we'll focus on hazard awareness. Next, we'll turn our attention to community, staff, and assets. And finally, we'll recap what we've covered and have a period for questions and answers. Before we get started, please take a moment to note the webinar control panel on your screen. I would like to encourage you to post your questions as they occur to you during the presentation in the GoToWebinar Questions dialog box. We will answer as many general questions that can be answered concisely as time permits after the webinar. Questions requiring longer answers and some technical questions that are better answered by one of our specialist colleagues will be handled individually after today's webinar. Please also note you can switch between telephone and computer speaker audio and adjust your view to full or partial screen. And again, please note today's webinar is being recorded. Protecting people, property, and the environment is among a gas utility's top priorities. That's one reason why regulatory compliance is a key gas utility function. Gas utilities need to know at all times the details of their pipe network, its connectivity, and what is going on within and around it. Spatial analysis then is key to identifying threats, evaluating and ranking risk, proactively taking steps to mitigate identified risks and threats, and staying the course of continuous improvement based upon measured performance. Zero incidents of loss containment is the goal, and regulators are one stakeholder group aligned with the natural gas industry's commitment to achieve that milestone. GIS plays a key role in regulatory compliance and more broadly in safety management. Visualization and analytics are key to understanding, and understanding is key to action. Together, they power the industry's move to better decisions, more operations in real time, and to a more proactive approach to damage prevention. GIS also enables important safety information to be shared broadly. Today, there are many gas utilities publicly sharing information on the location of high-pressure mains and planned future projects and their project status. And we're seeing a growing number of gas utilities interested in GIS-enabled gas outage restoration maps and dashboards. To speak to safety management in electric utilities, please welcome Pat Hull. Pat?
Thank you, Tom. I really appreciate your perspective on what's been happening in the gas industry. Electric utilities are quite similar in their safety concerns, and today we'll look at good examples from both. We'd like to get to know the audience a little bit before we get started with a poll. Since we're looking at safety in both gas and electric industries, let's take a moment to see what our split is between those industries. Please indicate your primary interest, gas, electric, or other. That's very interesting, a very even split between gas and electric. So that we can tailor our comments to this audience, please indicate how long you've been using ArcGIS. Less than 1 year, more than 5 years, or in between. Well, that's interesting. We have some new users as well as some veterans. So thank you all for being our customers. Today, our discussion will flow around the themes that Tom mentioned: regulatory compliance, hazard awareness, and then community staff and assets. Starting with regulatory compliance, like gas, electric utilities also face safety inspection requirements. Even in states where it's not mandated, most utilities follow what's called a standard of care for safety inspections to make sure that they're following industry best practices. Electric utilities are also concerned with the location of a few dangerous substances. PCBs, sodium hexafluoride gas, asbestos are a few. And these are subject to mandatory tracking and reporting requirements, also an excellent fit with GIS capabilities. As utilities, we have many commercial vehicles on the road every day, and driving may be the single most hazardous normal work activity. Hazard awareness in driving and route planning is ripe for location-aware safety improvements, and we'll take a look at that in a few minutes. It's fundamental. Safety really starts with awareness of hazards. One of the most powerful applications in terms of safety is to incorporate real-time data feeds for the purpose of better job planning. Avoiding hazards and better job planning help prevent workplace accidents. We also need to protect environmental resources, and these areas often are intersected by power lines, gas lines, or access roads. And in recent years, the requirements have increased substantially, making it more challenging to work around these resources. Providing employees with the best up-to-date information is really critical working in these areas. And if you've worked in emergency conditions, you know how important communication and information are. I think digital tools that are built into normal work are the best, particularly those that scale well in an emergency situation. Safety is a great reason to engage not only employees, but also the media, customers, public safety, and the general public. Crew location is of great interest, particularly when selecting who will respond to an emergency, who's close, who's properly equipped for the job, and could get on scene quickly. From a safety perspective, I always wanted a better way to help employees like troubleshooters that work alone, a way to know exactly where they are in case they got into trouble. The technology has come a long way to improve safety for those working alone, and we'll look at that too. We're going to move into the demos now. Before we do, one last poll question. Please indicate if you are currently using ArcGIS for safety in your organization. Good, it looks like many of you are using ArcGIS for safety activities. We hope we can give you some new ideas today that you can apply. Let's dive into an example of regulatory compliance, a gas valve inspection with a view from both the field and the office. Jess, I'm going to turn it over to you to start us off.
Thank you, Pat. Thanks for sharing those crucial key points about safety on the electric side. The regulatory requirements are just as important on the gas side. For example, PHMSA, or the Pipeline and Hazardous Materials Safety Administration, has a regulation that requires gas companies to do annual inspections on the distribution gas valves. Valves are a component on the pipeline that can be opened or closed to control the flow of gas. So, what's a way a gas utility can manage, monitor, and locate valve inspections? So let's say I am the manager of a team that performs asset inspections at a gas company. So every day I come into my office, my team and I can sit down and monitor the results of asset inspections by looking at this dashboard. But what exactly do we see on this map? So here we've got the extent of our service territory of the gas distribution network. Now at the street level, I can see more granular details about my network. Here I've got my pipelines, I've got my valve locations, and more importantly, on those valve locations, I can see whether or not the valve is functioning properly. Knowing the health of a valve is crucial in cases of emergencies where it has to be shut off or isolated. So to be confident in the operation of a valve, an inspection is typically done on each valve annually. I can view these individually completed inspections on the right list here, indicated by these green or red circles as to what was found on each valve. The red circles mean bad conditions were observed, such as corrosion, versus green circles show that the valve is in good condition. However, what is our overall progress on these inspections for the year? We can easily view this gauge on the left that tells me 74 valve inspections have been completed so far out of the 300 that have to be done before the end of this year. But where exactly are the valves that require these inspections soon? Just below it, we've got a list that prioritizes a valve based on approaching inspection due dates, so that I, as a manager, can assign my team efficiently to meet the deadline. When I click on these valves, it zooms to its location, and I can easily see the list here and the valves highlighted in orange that stand out against the valves that have already been surveyed. But how are these valve inspections done in the field? Let's actually go ahead and take a look at how Tyler, a field engineer on my team, performs a valve inspection to reach our compliance goals. Tyler?
Thank you, Jess. As a field engineer, I need to be able to quickly see which valves my manager is wanting us to inspect. So I'm going to use an ArcGIS mobile application to open a map showing the layout of our valves and the ones that specifically need to be inspected right away, which in this case is those clusters of valves highlighted in orange. Personally, I was asked to start as a specific valve, which its ID is B166. So I'm going to use my search bar here and pull up that specific valve. Once I'm ready to perform the inspection, I can read the pop-up information for that valve there on the left-hand panel. And as soon as I need to complete the survey, I just need to click the hyperlink below. You'll notice that it's launched a survey and it's even pulled in the values from the map that I was looking at earlier, such as the ID, the type of valve, its use, material, and diameter. In this section of the survey, it's also going to ask me to provide a sketch of that valve according to where it's located in relation to the intersection. So in this case, I'll just provide a few markups. I'll mark this as our valve. And then I'll specify some distances from those from the intersection. Make this at 15 feet. Okay, now I have my markup done. The next section is going to ask me how or if the valve is accessible. Now, if it weren't, I would select this as no, provide a few additional comments as to why I'm not able to access the valve, and then submit my survey. But in our case, I can easily access the valve, so I'll select yes. You'll notice that the survey has some logic baked into it that knows that if the valve is accessible, I need to be able to answer questions on its atmospheric corrosion, if it requires paint or lubrication. In this case, we have a healthy looking valve, so I'll mark those as no. I'll go ahead and mark the rest of the questions asking if it's properly tagged, if it's operational, and importantly, whether it's in good condition or not. Of course, since I'm in the field looking at the valve in person, I should take a picture of it and attach it to the survey. And lastly, as soon as I'm ready to submit my survey, I'll go ahead and sign off on it and submit that survey back into the office. So by using two seamless mobile applications, I was able to immediately see which valves needed to be inspected and used a smart survey form to complete the entire valve inspection. Jess, back to you.
So since I'm back in the office, I can go back to my dashboard and take a look as Tyler submits his survey from the field. So you'll notice this gauge on the left is marked in red at 74 and just updated to orange at 75, showing that we've completed our quarterly goal. Seeing this progress helps me answer to auditors and show that our gas company is actively striving to stay compliant with PHMSA regulations. Apps such as this can serve as the one source of truth for activities like valve inspections, so that a manager such as myself or a field engineer such as Tyler can view the same valve conditions and make sure we support safe operations and monitor asset health. Pat, could you actually speak on similar actions on the electric side?
Sure, that was very nice. The electric utilities have similar kinds of inspections. They need to ensure poles are able to withstand high winds without falling over. They need to ensure pad mounts are locked, secure, and not leaking oil. You know, as I look at this, I really appreciate the real-time dashboard view and the immediate visibility. Seeing the progress towards your KPI goal for the year would really help a manager make the best resource decisions. Okay, let's move into hazard awareness. Tyler is going to kick it off and show us integration of some real-time data feeds and how to use machine learning and spatial analysis to find hazards.
Great, thanks, Pat. I like to show how visualizing and analyzing information from a spatial perspective allows us to gain the insight needed to ensure the safety of employees, the network, and the public as a whole. What we're looking at now is a data set of car accidents that took place within Allegheny County from 2004 to 2017. And I want to use this data to identify the specific areas we want to avoid when we're routing technicians in the field or trying to transport oversized equipment. Now, the first thing I've done is run an emerging hotspot analysis that uses some spatial statistic tools as well as some machine learning concepts to identify where we have significantly high and low rates of car accidents. This analysis is also looking on how the data trends over the course of those 13 years. So not only do we see a large hot area around the Pittsburgh region, I can tell right dead center in the county that we have intensifying hotspots, meaning those that are currently hot and are only getting hotter over time. Right outside of that hub are more sporadic hotspots that indicate those that are frequently fluctuating between hot and neutral zones. And of course, if we look to the outskirts of the county, we have very low rates of car accidents, which all confirms that we're going to want to focus our attention in the Pittsburgh area. The next thing I've done is run a similar analysis, but just within our hotter region. So now we can start to identify those pockets where we can start to address and avoid if at all possible. So of course, the downtown sector of Pittsburgh is always going to have a ton of car accidents, but now we can start to see those pockets I mentioned, like in this area, this one here, and this one over here. That way, as we are routing our technicians, we may have originally considered a shortest path routing method, but of course that may overlap those areas with high rates of car accidents. We can incorporate this analysis into our routing so we can avoid those areas, and it may take a little longer to get there, but at least we're avoiding those high collision areas. Now in this use case, we're looking at how to better route our technicians or trying to transport that oversized equipment, but we can easily use the results of this analysis to understand which of our overhead assets are in danger of frequent car accidents. Now what we just saw is how we can analyze historical trends to provide new insights on how to protect our employees or the network, but it's just as important to monitor real-time threats as well. Weather, for example, is something that is constantly changing and of course has a great impact on safety. Now the colored areas we see on the map are actually live weather warnings coming directly from NOAA that indicate anything from wind advisories to winter warnings or potential flooding. We can also incorporate some other real-time weather feeds, such as wildfires that have been reported by local agencies. We can even tap into NASA's satellite analysis that detects thermal activity, which may suggest a potential wildfire occurring in those red dots. So it may not be reported, but there is a chance that we have a wildfire there. And lastly, we can also look at real-time lightning strikes as well. And with those in particular, we can start to see where we have infrastructure, where we have network, substations, poles, lines, and customers that may be in danger after a lightning strike. Now, this weather map we've incorporated within the dashboard that we're using to monitor several types of events that can impact our technicians working in the field. The main map shows the current locations of our trucks and their proximities to hazards such as downed wires, vegetation encroachment, or even dangerous animals. Now, the hazards in the map are actually being reported by the technicians themselves while they're already in the field performing their jobs. So to demonstrate that, we're actually going to send Jess into the field this time and have her report a hazard for us.
Thanks, Tyler. So I've got my gear in the truck. I've got my Mac Cafe. So I'm driving along the Hoover Reservoir in Westerville, Ohio. As I'm driving, I see an overhead line that's fallen. So I immediately pull out my mobile device and use Collector to report the hazard so the rest of my team is aware of this incident. So I can pinpoint the fallen line's exact location by zooming in and panning on the map. And on the left, I can see the different common hazard categories that a utility might want to report. In this case, it's a wire down. I can add in additional descriptions and of course set a high priority for this case. And since I'm on site, I can go ahead and attach a photo that I've taken on site or a photo I already have in my library. So I'm going to go ahead and add this photo of electric poles. So now that this report has been submitted, it's automatically shared with other field engineers and anyone else in my organization, such as the customer service group. They should definitely be aware of the report so that they can be informed when customers call in about any outage issues. And lastly, my manager, Tyler, can see this back in the office.
Great, thanks, Jess. So now that we had her input a new hazard, you may have noticed that our dashboard has been updated to reflect just that. We see that hazard there by the Hoover Reservoir, and we can also see that our truck has changed its symbology or the icon to more of a red truck, since it's contained within that hazardous zone. We've also had the widgets around the dashboard update as well to give us a total count of how many trucks and staff members are within those zones. Since we're tracking these trucks in real time, as they begin to move out in the field, we can see those locations reflected in real time and will be indicated on which of those trucks and staff members are within a hazardous zone. Now, of course, we know that as technicians go out to the field, they're usually not staying in their trucks to perform their jobs. So if we zoom into a particular staff member, we'll see that they're parked over here at this park. And as the employee in this case is walking from the truck, we can monitor their walk traffic as well. That way, as they encroach and get close to a hazardous zone or area, we'll see the dashboard be reflected to show that the staff member themselves are within that hazardous zone. Now, in this case, we've set the alerts to show up in the dashboard, but we can also include other triggers that can launch either text message alerts to the employee itself or even email blasts to their manager. So whether we're analyzing events from a historical angle or from a real-time perspective, it's crucial to be aware of any potential hazard that can impact the safety of your employees, the network, and of course your customers. Pat, back to you.
Thanks, Tyler. I wish that I'd had that kind of data when I was in operations. It definitely would have helped increase hazard awareness. Would have removed a lot of guesswork and literally cut hours out of some jobs. Let's shift our attention to communicating externally. with customers and look at some examples from both gas and electric. There is a saying in electric line work, some of you have probably heard it. It goes like this: look up and live. It means look up at the wires, recognize the danger, and you will be safer. We're going to go to the other side of the world to see how they're applying the look up and live idea in Australia, where it's already tomorrow. Jess, are you ready to take us to Australia?
I'm always ready for Australia, Pat. A lot of utilities today communicate to the public through mail, websites, social media, and even maps. So let's go through some public maps that utilities have out there today to show their general asset locations so that customers are aware of the proximity to major gas pipelines or even high voltage electric lines. Energy Queensland Group is an electric utility company based in Queensland, Australia. Their public map is called Look Up and Live, referring to their entire overhead wire assets. On this map, the red lines represent their transmission overhead network. As we zoom in, we can see more granular detail of their distribution network, highlighted here in the blue and green lines. So what safety reason is there for a utility to publish a map of their assets? Internally, a company may want to limit the amount of lawsuits and liability. Externally, a company may want to simply provide easy-to-use tools for people to view assets, or more importantly, the risk of hitting an asset. A good use of a map like this is for planning farming activities, especially in rural Queensland. For example, when crops are ready for picking, farmers often use tall vehicles like these harvesters.
Jessica, let me jump in for a second. I just want to point out that this is a very dangerous situation. Now, a farmer knows his field, but these contract harvest crews that move from farm to farm do not. I mean, look at that metal discharge chute extending up in the air. That is an accident waiting to happen. Following proper procedures in farming does require a job site briefing with a specific discussion about power lines. And this app you're going to show us supports that very nicely.
Right. That's a very good example on how harvesters and other vehicles, such as crop dusters, could actually be a harm to any electric assets.
Oh my goodness, look at this. So crop dusters fly very low and routinely move from farm to farm. I mean, imagine coming in at 180 miles an hour, 15 feet off the deck with a thin energized wire across your path. That's a recipe for disaster. When doing flight planning, pilots need to understand the location of power lines. Their life literally depends on it. So an application like this is fantastic for that.
Right. Knowing location is super important for any worker who may not be familiar with the area. And there are many times that farmers might hire contractors to go through with these cases. So here's an area where I think that a high risk of a new contractor or worker coming on site may potentially hit this overhead wire on the right, crossing through the middle of this field.
Jess, I'm picturing someone driving a harvester down that row. They've been up all morning. They've got their headphones in, and that line cuts diagonally across their path. That could creep in front of them so easily. Wow. What else does this app show?
Right. So this map is not just being able to view asset locations, it's also interactive. So if I were to click on this line here, Energy has actually provided a lot of safety links in their pop-up. So they've really stood up a great example of how electric asset locations are shared with the community. Let's actually go ahead and take a look at how a gas company does something similar. SoCal Gas provides a public map for general information on the location of their gas transmission and high-pressure distribution pipelines. Here, they provide a description about pipelines, as well as a link to PHMSA, which earlier I discussed is one of the major agencies in the gas industry, showing that safety is a considered factor in providing this map. So since SoCal Gas has such a large service territory, they provide their maps based on county. So let's actually take a look at Los Angeles County. On this map, the dark blue lines symbolize their transmission lines, and the light blue lines symbolize high pressure distribution lines. So the map of Los Angeles County simply informs customers if there's a major pipeline near their house. So if I zoom in here to the Culver City area where the 10 and the 4 or 5 meet, you may most likely live along this high pressure distribution line. So aside from asset locations, utilities like to be transparent with other events like construction and outage statuses. So let's take a look at some maps that Peoples Gas and Xcel Energy have published. Peoples Natural Gas Company is based in Pennsylvania, and they published a map called Future Work. This map shows current and future construction projects which are aimed to improve overall pipeline infrastructure. This map is released so that customers can see where and when they are doing work near their areas. So at this level, the locations are displayed as points. But if we zoom into the downtown Pittsburgh area, into this cluster here, we can actually see those points turn into polygons that are color-coded based on the status of the project, such as orange is ready for construction and blue shows completion. By clicking on these project boundaries, I can see information of the status in detail, as well as the estimated quarter time frame for completion or restoration. So if you're a customer of Peoples Gas, check this map out to see if there's work being done near your area. And lastly, on the electric side, Xcel Energy is one of the largest electric utilities in the US, covering 8 Western and Midwestern states. They make their outages reports available across all their different territories. So when we took a look at Tyler's weather map earlier, we actually saw some rain activity going up here in the Minnesota-Wisconsin area. So let's take a look at what's happening over there. So as we zoom into these clusters, we can now see the individual locations of these outages. This one in particular shows that 56 customers were impacted yesterday, and that Xcel Energy was able to restore it. So you can see other information as to how they were responding to these individual issues. For a customer looking at this map, if a reportage is not seen, they can actually go ahead and hit report an outage. So Xcel Energy has provided an easy-to-use tool for all their customers throughout the different states. So this is a great example of how utilities share information to the public through the power of maps. Pat, have you ever used or are you familiar with these examples?
I am. I'm familiar with the implementation at Xcel Energy. That solution was spun up very quickly as a managed service and hosted entirely in the cloud. You know, outage maps like that get a lot of hits in an emergency. The great thing about a cloud-based solution is that they scale up so well with almost unlimited resources and without having to maintain costly servers on premises, waiting for the day that they might be needed. Well, today we've seen some great examples of ways that GIS is used to support utility safety objectives. We saw tools that support regulatory compliance and equipment inspections. Those improved field work for inspections and also increased situational awareness in the office. We looked at increasing hazard awareness by incorporating outside data sources, using analytics, and communicating those results to the field. The same could be done with operational data that came from your SCADA system. That would allow you to better understand real-time conditions that potentially threaten staff or assets. As we've seen, there are many ways that GIS can support utility safety. A webinar is so much more meaningful when you see examples of what your peer utilities are doing. And I'd like to take just a moment to thank those that allowed us to share their stories listed here. I know members of this audience are doing great work that others would likewise find valuable. And your story doesn't have to be earth-shattering. It might be something you even take for granted, but it could really help somebody else. Tom and I would love to be able to share your stories with others. And if that's something you'd consider, please note so in the survey at the end, and we'll contact you. As far as next steps, we have many options for you that Tom discussed, upcoming webinars and upcoming events. We welcome you and invite you to all of those coming up this year. Esri has numerous ways for you to stay up on the latest. Please check out our electric industry blogs on energycentral.com. There we are. These are very popular and key in on some of the latest industry issues and trends. Finally, social media is the best way to stay informed these days, and we work hard to curate all of the best gas and electric content for you on Twitter. Twitter for Esri Utilities has exploded this past year. So see for yourself and follow us at Esri Electric Gas. You'll see other options here, including the community on LinkedIn, a direct email address that you can use, as well as the GeoNet technical community link. I think we have time to take a few questions. We have quite a few coming in. Let's start with the first one. How are you tracking the trucks and showing it on a dashboard? And is that different from tracking employees?
Yeah, Pat, this is Tyler. I can take that one. So we perform the tracking using a couple different methods. So starting with the trucks, we use an extension called Geo Event Server. And that product's really designed to be able to monitor various types of real-time data feeds. So in this case, we simulated tracking the locations using an AVL feed that'd be coming from the trucks. So when we're ingesting a new data feed, we're usually processing it in some way. An example today, we had the dashboard update the map, so we can see the trucks going in and out and the staff members going in and out, and the widgets around it. So we got that count as well. We also used a newer ArcGIS application separate from GeoEvent called Tracker. And that's really was designed to be able to monitor and track the movement of users and employees in this case.
Okay, that's good. A similar related question, does the mobile solution work in a disconnected mode?
I can take that one on, Pat. So yeah, so all the mobile solutions that we showed today do work in disconnected and offline environments. So a lot of utilities actually have assets that are in remote areas, like in the mountains or in the middle of the desert with really poor cell service. And so being able to view those maps offline before visiting that site allows you to do that, as well as actually editing data, such as the inspections that we saw Tyler do, and actually queue it up on your device until you're in an area with Wi-Fi or good service. And then it will then sync up and re-upload once you are there. So yeah, so all are available in disconnected areas.
Very good. I do see a number of people asking about the recording. Just a reminder that the webinar is recorded, and you'll receive an email with 1 week with a link to the video. Okay, here's a question about the weather data. It says the weather data appeared to be live. Could you tell us again where that came from?
This is Tyler. I can take that one too. So the layers that we pulled in for the purposes of the weather map today were actually mainly came from our Living Atlas. So that's really where we curate and make all the different data layers we make available to ArcGIS users is all through the Living Atlas. And a lot of those layers are not even sourced by us. It's actually coming from our partners like NOAA and USGS like we saw today. So as soon as they make an update within their system, we're seeing that reflected in real time. So for the weather warnings, that's usually around 5 minutes. And of course it varies per each layer, but we're pulling those in directly from the source, and they're all available today in the Living Atlas. With the exception of one that we saw today, which is actually the lightning strikes. And it's worth mentioning our partners are also making several different types of data layers available as well. So AccuWeather has actually provided that real-time lightning data feed for us.
Tyler, in this same data theme, there's a similar question. They say, I was surprised to see a Bing base map. Is that an option?
Sure. So yeah, so talking on for the partner data layers, that's another partner we work with to provide base maps. And I think that was in one of the outage viewers we saw today. So that's still running on ArcGIS technology. We're just leveraging some partner content to enhance some of the base maps within our within that web map.
All right. One more about mobile. Where did the mobile apps that you demonstrated come from?
I can take that one. So we did show a variety of mobile applications today. So let me break this down by each demo that we did. Just a reminder, everything we've showed in terms of mobile apps are available in the App Store. In that first demo in the gas valve inspection, I had Tyler view a map in Explorer for ArcGIS, and he was able to launch Survey 123 to fill out that gas inspection form. So those are the two apps, Explorer and Survey 123 in the gas demo. In that second demo, where we had myself actually go out and collect a hazard report, that was actually using Collector, and then showing the results of the person walking into a hazardous area. Tyler mentioned that that was actually Tracker, the results of ArcGIS for Tracker, or Tracker for ArcGIS. And all these 4 applications, like I said, are available on the App Store.
Jess, we have a little interest around how to adapt to these mobile inspection apps. Could you comment on what it would take to modify the logic that was demonstrated for a complex electric utility?
Sure. So that could actually have a variety of different answers, because it could be dependent on the data size of that utility, as well as how many inspections and what their forms look like in terms of the type. So really it could vary, but the good thing to know is that every app that we show today is all configurable, meaning against your data, you're just turning settings on and off and doing some adjustments. We like to call that COTS, configurable.
Yeah, Jess, I just might add on. So I think all the applications on the web or mobile were all configurable. So if you need to create a survey that's for a different type of survey you need to build, then you can certainly configure that pretty readily. I did want to mention that we have a pretty extensive developer platform as well. So not all our mobile applications you can develop on. Survey 123, you can a bit more, but if you wanted to build a more custom application that's more tailored towards your organization or hits on some key functionality points that maybe our applications don't support out of the box, you can certainly leverage those developer resources.
Thanks, Tyler. Here's a question. Will Tracker for ArcGIS be coming to ArcGIS Online?
Yeah, so it's certainly on the roadmap, but it was released at our 10.7, or it's the first version of Tracker in a full production is at 10.7, but eventually it will be brought into ArcGIS Online.
Okay, great. There's some general questions around software. The question is, are the apps you use today Esri developed programs? And maybe you could comment on what software is running for these demonstrations.
Yeah, so I'll speak on the first point. So in terms of what we demoed, we saw Operations Dashboard. That was a web dashboard application. That is an out-of-the-box Esri application that's either available at ArcGIS Enterprise or ArcGIS Online. And then the mobile applications we saw today are available in the App Store, so you would use those to download. But I think a point worth mentioning in terms of the web and mobile demos we saw today, you would either need to deploy ArcGIS Enterprise, which is our on-premises solution, or ArcGIS Online, which is our SaaS offering. So if you have one of those deployed and the appropriate licensing, you can deploy the apps that we saw today. And then if we're speaking on our demos that we showed, we also tapped into ArcGIS Pro to perform the emerging hotspot analysis and to do some of the routing as well. And that would be a separate license outside of Enterprise and Online called ArcGIS Desktop.
All right, here's a question. Can messages such as emails and text be pushed from GeoEvent server? When the worker crosses into a red zone, send a text or email.
Definitely, definitely. So in our demo, we just had the dashboard update, but you can easily configure GeoEvent to be able to send a text message, alert, or email, and you can obviously specify who that would go to. So maybe the text messages goes to the tech in the field, and the email blast is sent to management and whatnot.
Right, great question. Coming down to the end here, here's a question. Is the data you used in utility network?
Yeah, so I would have to confirm that because we looked at several different networks. We saw one based in Battle Creek, and we also based one demo in Westerville. So we would have to confirm if those are, but I do want to stress that we could incorporate information from the utility network within the demos that we saw today, especially since in our case we use those as more visual references and pulling up attribute information like what we saw Jess do. That can definitely leverage something that's stored and maintained in the utility network, and utility network actually makes that much more seamless to be able to incorporate that information within web and mobile applications.
All right, well, thank you. We really appreciate all of the questions, and we'll direct any remaining questions to an appropriate resource for you. In conclusion, there is no higher priority for utility than safety. As we've seen, Esri technology offers some concrete ways to enhance all kinds of utility safety. The big idea is to provide the right information at the right time to make the right decision. So thank you for being our customers and for participating in this webinar. I hope that you found it valuable. Please take a moment for a very short survey at the end. We would really appreciate your feedback. And if you would like to continue the conversation, there is an option in the survey to indicate that. We would love to talk with you one-on-one. Thank you for your attention. Please be safe always. This concludes the webinar.